Hi guys, this is Dr. Manjunath Chennapur from Anveshana Academy, Bangalore, India. Dear students, in the previous class we discussed one numerical on Otto cycle in two different methods. Today I am going to solve some more numericals on Otto cycle. Okay, so numerical on Otto cycle. Okay, so I will read the problem. The minimum pressure and temperature, just a minute. Okay, fine. The minimum pressure and temperature of Otto cycle are 100 kilopascal and 27 degrees Celsius. The amount of heat added to the air per cycle is 1500 kilojoules per kg. Okay, so determine first one the pressure and temperature at all points of the air standard Otto cycle. Okay. Second parameter is the specific work and thermal efficiency of the cycle for a compression ratio of 8:1. Take for air Cv equal to 0.72 kilojoules per kg and gamma equal to 1.4. This is one problem of what? Otto cycle. Dear students, again Otto cycle, when it comes to Otto cycle, it's an engine. When it comes to engine, piston and cylinder arrangements play a very important role. When the piston moving from BDC to TDC, compression, again from when it is moving from TDC to BDC, expansion. Because of these two, expansion and compression, we are going to get the work done. To get expansion, we need to do some heat addition. Once the work is done, we need to remove the heat, that is heat rejection. So heat addition, heat rejection, compression and expansion, four processes will play a very important role in the Otto cycle. Those four cycles are well explained by the great scientist, that is Nicholas Otto. Okay, so now I will go to the problem. That is what is the first step? First step, we need to list out the given data. What are the things he has given? He has given a minimum pressure. Minimum pressure means what? Where you can get the minimum pressure? You can see the PV diagram. Already I hope you are familiar with what PV diagram now. PV diagram and TS diagram for Otto cycle. So once I will go to the PV diagram and working of this engine schematic diagram. I will go directly and I will try to solve the numerical. Okay, so the minimum pressure he has given 100 kilopascal. He has given 100 kilopascal is nothing but what? So 1 bar actually. So what is 1 bar? 1 bar is equal to 10 to the power of 5 Newton per meter square. That is nothing but what? 1 pascal is equal to 10 to the power of 5 Newton per 1 pascal is equal to what? 1 Newton per meter square. Okay, that he has given. That's fine. What is temperature? Minimum temperature also he has given, that is 27 degrees Celsius. But he has given in degrees Celsius, converted into Kelvin, that becomes what? 300 Kelvin. Then in the problem itself he is telling some amount of heat is adding. That amount of heat addition is represented as a QS. That QS is equal to, he has given 1500 kilojoules per kg he has given. That's fine. And also he has given compression ratio. What is the compression ratio? RC is equal to V1 by V2. So the 8:1 he has given. That means what? V1 is equal to 8, V2 is equal to 1 he has given. That means what? RC he has already given, that is RC is equal to V1 by V2, 8 he has given. Then specific heat for air at constant volume he has given 0.72 kilojoules per kg, that is CV. Then gamma equal to 1.4 he has given. Dear students, what I will do? What you have to do? You have to draw the PV diagram and I have to mention all the given parameters. Now at minimum pressure, what is the minimum pressure he has given? That is P1. I can write it in terms of bar, that is what? 1 bar. Fine. Next, what is temperature? He has given 27 degrees Celsius, that is 300 Kelvin. Fine. Next, the amount of, then he is going to supply heat at this particular point, that is heat addition is equal to 1500 kilojoules per kg he is telling. That also done. Okay, then we need to calculate, that is very important here. Now we need to calculate pressure and temperature. So pressure, what is P2 and T2, what is P3 and T3, what is P4 and T4, what is P1 and T1, but P1 and T1 he has already given, no need to calculate. That means what we have to calculate all the temperature and pressure at each point of the Otto cycle. How to solve this now? We will solve this numerical step by step. What is first step now, dear students? The first step is given data, that you are listing the given data that we have done. Second is to find the pressure and temperature at all point with the help of pressure ratio of different process. Now what I will do, I will go with what first process, that is 1 to 2. That is, if it is adiabatic compression process, we have the relation. What is that? P1 by P2 is equal to V2 by V1 to the power of what? Gamma. So what is V2 and V1? V2 he has given 1, V1 he has given 8. Okay, then gamma is he has already given in the problem, that is 1.4. Then P1 by P2 we can calculate, and also the P1 also he has given, that is 1 bar. Then only unknown is P2. So I can calculate the pressure P2 at point 2 in the adiabatic compression process. Then how to calculate? I am having this equation. So now you can see here now. Now what I can do here now? So I need to calculate the pressure and temperature at all points. To calculate that, we are having an equation first step. But dear students, try to understand the first problem thoroughly. How to understand the problem thoroughly? You can see here now. What all things he has given that you have listed out. What is that? Initial pressure P1 he has given. Initial temperature he has given, that is T2, T1. Then he is supplied certain amount of heat as a QS, that is 1500 kilojoules. That also you have taken. Compression ratio he has given. That compression ratio you can take RC is equal to V1 by V2 is equal to 8 he has given. The next, specific heat at constant volume, that means what? CV he has given. Then specific heat ratio of specific heat also, gamma also he has given, that is 1.4, that is 0.74 something. These are the data he has given. Then what you have to do to calculate the pressure and temperature at all point, what you have to do, you have to go with the step by step. First process 1 to 2, first process 1 to 2, next second process 2 to 3, second process 2 to 3, like that, next 3 to 4. Then we have to go like this. Then only what you can do, you can get pressure and temperature at all point. Now I will take first point, adiabatic process, that is 1 to 2. 1 to 2, what you can do now? Do calculations. You can get the P1 is there, right? If you are going with process from P1 to P2, you can calculate the P2. Then T1, T2. When we are considering process 1 and 2, you can calculate both pressure and temperature. That means what? P2 and T2 you can calculate. Similarly, go to process 2 to 3. When you are going to calculate, going 2 to 3, right? You are adding heat here now. That heat also you can calculate there. With help of heat equation, you can calculate something else. That also is possible, because next constant volume process, because heat you are adding it at a constant volume. If it is constant volume, that means what we know already. We P3 by P2. P3 by P2 is equal to T3 by T2. Some constant relations will come. That also, with help of that, we can calculate other things also. When we are adding heat, right? When we are transferring heat, that heat transfer is nothing but what? QS we can take M into CV into T3 minus T2. T3 minus T2. That equation also we can use. With help of that, what we can do, we can calculate the heat transfer, and if required, you can calculate other temperatures also. Once it done, what we can do now? Once you calculate temperature and pressure at all point, what you can do? You can calculate the specific work and thermal efficiency of the cycle. So this cycle is related to what? Otto cycle. Otto cycle means what? Otto cycle or constant volume cycle, or we can call it as a petrol. This cycle is used for what? Designing the petrol engine or gasoline engine. He has given some basic data. With help of that data, I am going to calculate the pressure and temperature as well as efficiency and work done from the Otto cycle now. So what I have to do then, dear students, I will try to list out the given data. What are the given data he has given? So specific heat at a constant volume, that is important. Constant volume also will come, constant pressure also will come, but it is a constant volume process. Otto cycle. Constant pressure process is diesel cycle, that we will see it later, but it's a constant volume process. Hence he has given specific heat at constant volume 0.72 kilojoules per kg. The ratio of specific heat ratio, that is gamma, is equal to 1.4 he has given. Initial pressure he has given in terms of kilopascal. 100 kilopascal is nothing but what? 1 bar. Then initial temperature he has given 27 degrees Celsius, that we can convert it into Kelvin as T1 is equal to 300 Kelvin. Now he is supplying certain amount of heat at constant volume, that is QS is equal to 1500 kilojoules per kg. And also in the problem itself he has given the compression ratio, that is V1 by V2 is equal to compression ratio, that you can take it as small rc or capital RC or small r itself, that is equal to 8:1 he has given. Okay, so that also he has given. Now he has given all the data. Now what I will do, I will go with step by step. Now what is first process, we can see here dear students. Now as I told, what is the first process equation, you can see here. Now what is that? Okay, so P1 by P2 is equal to V2 by V1. What the P1 he has given, V2 V1, by that ratio he has already given, gamma also is given, but the only unknown is what, P2. With help of this relation, so what I can do, P1 there, 1 minute. Okay, so fine, so P1 pressure at point 1 divided by P2 is equal to V2 divided by V1 to the 4 of what, gamma. This is the equation, this is the relation, I can use it at adiabatic compression. With help of this equation, I will try to take the value of P2, because my first intention is to calculate the pressure, temperature at all points. So to calculate that, what I will do, I will use the adiabatic compression process first. Now what is that, you can see here now. So that equation I will use here now, that is P1 by P2, P1 by P2, P1 by P2. Okay, the P1 is 1 bar, P2 is, I don't know, I will keep it as it is. Next it is V2 by V1, right? So already we know P1 by, equation is what, relation P1 by P2 is equal to V2 by V1 to the 4 of what, V2 by V1 to the 4 of what, gamma is there. So P1 is equal to 1 bar, P2 is equal to, I don't know the value, I will keep it as it is, but V2 is how much, 1, the reverse case, the 1 divided by 8, V1 is 8 actually. Substitute and do simplification, you are going to get the value of what, P2 is equal to 18.38 bar. Okay, so that we have done it here now. Fine. Now so you can substitute now, you can substitute here now. So what is that, just a minute, you can substitute 1 divided by 8 into bracket to the 4 of what, 1.4. well, how much you are going to get, 1 by 8, just a minute. Okay, what we can do here now, this value how much you got, 0. How much, just a minute, how much you got, 0.054, 0.054 you got this value. So that is 1 by P2 is equal to 1. So 1 by, you can write it here now, what we got, 1 by P2 is equal to 0.054, you got it now. So P2 is equal to, so therefore what we can do, P2 is equal to 1 divided by 0.054. So how much you will get, 18.38 bar you got, that is what, pressure. So once you know that, so with help of T1 and T2, so during adiabatic compression process, variation of temperature with pressure, we can write the equation, one more equation. What is that, T1 by T2 is equal to, we know already, T1 by T2 is equal to P1 by T2, P1 by P2 to the 4 of what, gamma minus 1 divided by gamma. So now what is T1, he has given 300 Kelvin, but T2 I don't know, keep it as it is. Now what is P1, we know already. What is P2, already we have calculated. What is gamma, that also you know all the values. Substitute, you will get the value of P2. P2 is equal to how much, that we can see here dear students. So sorry, T2 is equal to how much, do simplification and calculate, you are going to get the value of T2 as 689.22 Kelvin. Now process 1 to 2 is done. Now with help of process, now you can say now from process 1 to 2 I calculated P2 as well as T2. Now what I will do, I will move towards next process, that is T2 to T3. When we are going to consider process 2 to 3, that means what, heat addition, If you are considering 2 to 3, you can calculate the value of what? P3 and T3 if you consider process 2 to 3. So what I will do now, I will consider process 2 to 3, that is a heat addition. So right, heat addition, that is nothing but what? Heat addition is represented as a QS now. So what is the heat addition now? We know already equation, QS is equal to M into CV into T3 minus T2. Okay, assume that mass equal to 1 kg. Per kg we are asking always, kilojoules per kg means what? M equal to 1, neglect that M. So QS is equal to, he is already given, heat supplied, yes, 1500 he has given, M is 1, QS he has already given, fine, 1 minute, fine, okay, QS he has given, M he has given, CV also is given, T3 you don't know, keep it as it is, T2 you already calculated here, then only unknown is what? T3. Do simplification now, substitute all values. QS is 1500, M equal to 1, CV equal to 0.72, then T3 is unknown, keep it as it is, minus T2 is equal to 689, already we calculated. Do simplification, you are going to get the value of T3 as 2772.5 Kelvin. So we know that this is what? At constant volume, right? We are supplying heat at a constant volume. If it is a constant volume, P by T is equal to constant. Now what we can do? You can apply this law that at 0.19, at 0.2 and 0.3. So then pressure and volume variation, pressure and temperature variations I can write like this here now. What is that? Pressure at constant volume process. P2 by T2 is equal to P2 by T2 at constant volume. P3 by T3 at constant volume. If it's so, then I will write the equation now. So what is P2? I know already, I will substitute here. Then what is T2? That also I know, I will substitute. P3 I don't know, I will keep it as it is, but T3 I know, I will substitute. By doing simplification, I am going to get the value of P3 as, I am going to get the value of P3 as 73.4 bar. So P3 also done. Now what I will do now? T3 I calculated, P3 I calculated, then what I will do? I will move towards process 3 to 4. What is the process 3 to 4? Adiabatic expansion. If it is adiabatic expansion, variation of pressure versus volume, we have an equation. What is that equation? P3 by V4 to the 4 of gamma minus 1 divided by gamma is equal to V4 by V3 to the 4 of gamma minus 1. But this is the equation, but you have to see, dear students, now what is the value of V4 and V1? So V4 is equal to V1. You can see the PV diagram, because heat is rejected at a constant volume, so V1 is equal to V4. Similarly, heat is added at a constant volume, so V2 equal to V3. So therefore, what I can say now, V4 is equal to V1, V4 is equal to V1. So the next, V3 equal to V2. So then this equation I will modify now. So P3 by P4, just a minute. So P3 by P4, P3 by P4 I will write it as it is. Gamma minus 1 I will write it as it is. That left hand side term I will write it as it is. What is V4? V4 is equal to what? V1. Yes, I will write it V1. What is V3? V3 is equal to V2. I will write it V2. Now V1 by V2 is what? Again, V1 by V2 is what? Compression ratio, that is R equal to 8:1 they have given. That is fine. Now what is P3? I will try to substitute all values here now. What is P3? You already calculated. Substitute here. What is P4? P4 you don't know, that you keep it as it is. Then other values you know already. Substitute. V1 by V2, 8 you know, gamma you know, you do simplification. Only unknown is what? P4. Do simplification and calculate the P4 value. So the P4 value is how much? 4.02 bar, dear students. The pressure is decreasing. You can see here now, when it comes to P3, right? P3 value is 73.94 bar. It is a maximum pressure. So you can get P3 at a maximum pressure. But when it comes to P4, right? Pressure is decreasing. And also temperature is also going to decrease, but volume is increasing. That we can see the values also. Now if it's so, again what will happen now? T3 to T4, the pressure. Now you have written the equation for pressure and volume variations. Now you write down pressure and temperature variations. We have an equation. What is that? T3 by T4 is equal to P3 by P4 to the 4 of gamma minus 1. I will use this equation. I will try to calculate other things now. Now what I will do now? So what is T3? I already calculated somewhere else here. T3 in the previous, we can see that T3, but T2 is unknown. I will write it as it is, but P3 and P4 are already calculated. Here it is a P3 and P4. I will substitute here. Then gamma is 1.4 minus 1, divided by 1.4. Do simplification, you are going to get one more value. You are going to get one more value. That value is nothing but what? T4. So T4 is equal to this much. Dear students, you calculated T1, P1, T2, P2, T3, P3, the next P4, P1. P4 you have to calculate, that you have calculated, but T4 you have calculated, but P1 and P2, so P1 and T1 he has already given in the problem. So what have you done? P1 and P1 you have calculated, sorry, it is given. P2 you have calculated, P3 you have calculated, P4 also you have calculated, but T1 he has given, you calculated T2, you calculated the T3 and T4. That means what? Temperature, that means what? Pressure and temperature you calculated it all, point 1, 0.2, 0.3 and 0.4. You calculated all the values. Now what is the next step now? Next step is what? Next you need to calculate the efficiency and work done. To calculate the efficiency we required work done. How to calculate the work done? Specific work. That means what? Qs minus Qr. What is Qs now? You are supplying heat at this particular point, right? Then how to write the equation here now? Qs is equal to M into, at again constant volume heat process, Cv into highest temperature is T3 minus T2. So what is M value? That is 1. Cv 0.7 something else. Then T3 you already know. T3 value and T2 you substitute. You will get the value now. Now this is the equation. Qs is what? I will write the equation now. This equation. This is what heat supply. Then heat rejection. Where the heat is getting rejected? Here. Again it is what? Constant volume. Again M into constant volume Cv into what is the highest temperature now? T4 is the highest temperature, that is T4 minus T1. This is what? Heat addition, and this is heat rejection. So therefore heat supplied minus heat rejection is nothing but what? Work done. That I will write it here equation. So here dear students, MCV is a constant. So therefore what I will do? I will take it outside. The remaining inside what? T3 minus T2 minus T4 minus T2. So therefore T3 is equal to this much. T2 you already know. T4 you know. T1 also you know. Do simplify. Then what you will get? You will get the specific work. Total work you are going to get is how much? 847.2 kilojoules per kg of air. This is the amount of work you got it. But how to calculate the efficiency now? To calculate the efficiency of the air standard cycle of Otto cycle, we know the equation, standard equation. Already we have derived that equation. What is that? Efficiency of air standard cycle is equal to 1 minus 1 divided by Rc to the power of gamma minus 1. Rc he has given in the problem itself 8. Then gamma also is given. Do simplification and calculate the efficiency. Then what? How much you will get? You will get the value of efficiency as efficiency of air standard cycle is equal to 56.4%. This is how to calculate the calculate the efficiency of the Otto cycle, dear students. Now what are the findings now? What are the final answers? That final answers you can mark here now. What is P1? It is given. P2 you have already calculated. P3 also you have calculated. P4 also you have calculated. Dear students, at the end of your calculations, please put up final answers in a box. That would be better. Then T1 he has given, but T2 you have calculated. T3 also have calculated. T4 also have calculated. This is what our first finding. That's fine. Then second finding, you need to calculate the specific work output and thermal efficiency. That is at 847 kilojoules per kg. Then 56.5 joules. Okay. These all are what? Point 1. At point 1, dear students, how much pressure? Please mention here now. So P1 is equal to 1 bar. The next T1 is equal to, what is the T1? T1 is equal to how much? That you have to mention 300 Kelvin. Similarly, go to the second point. Second point, what is the second point? You can see here now, temperature and pressure. Sorry, pressure and temperature. Okay, fine. Next, you have to draw the diagram. You can show this now. P2 is equal to how much? 18 bar, 18.38 bar. Then T2 is equal to 689 Kelvin. 689 Kelvin. The next P3 is equal to how much? P3 is equal to 73.9 bar. 73.9 bar. Then T3 is equal to, what is T3 value? 277.2 Kelvin. Okay. Similarly, what is P4? P4 is equal to, what is the P4? P4 you can see 4.02 bar. Okay. Next, what is T4? Sorry, T4 is equal to 1207 Kelvin. This is how to solve the numericals. Okay, at the last, with the help of this, what we can do, we can calculate the specific work done, that is 847. Then thermal efficiency is 56.5%. At the end, you have to draw this PV diagram, and you have to show all the temperature and pressures. Beside to that, you write down the efficiency. Efficiency is 56.5%. Then work done is equal to 847 kilojoules per kg, you have to mention. This is how to solve the numerical. Okay, so dear students, I hope you understood the numericals on Otto cycle. Here one my small request, please do subscribe my channel, like and comment, and help me and support me. Thank you.